Okay, this is actually additional to see what are some of the other possible analysis tool that I didn't cover in the tutorial part 3. Okay, let's just for example that we want to find out how is the basketball moving in a horizontal manner. Okay, what we have analyzed so far is actually vertical, but right now maybe we want to find out what is the motion in terms of horizontal. So you can actually see it for yourself. You change this to x, okay, and then maybe you change it to velocity x. Okay, so let's say if you want to find what's the velocity, there's actually several ways that you can actually achieve that. Okay, one of the ways, again, we tap upon our knowledge of um, uh, kinematics. As the velocity is the gradient of a displacement time graph. So if you want to find out what is the velocity, so you use the displacement time graph, you click on it. Okay, so okay, you find that there are some data that we don't want. Okay, so just uncheck it. Then you find that, well, if you want to find out what's the velocity, okay, you can actually again use the gradient. Okay, you can use the gradient of the displacement time graph. So you find that this one is obviously it's divided into two parts. Okay, where the ball is traveling and then after that it bounces and it becomes slower. Okay, so you see that it is 3.04, okay, or 3.05. Okay, the second part is actually 7.8. So this is actually 7.8, but it's -1, so it's 0.78. So you see that actually using a displacement time graph, you can actually obtain the speed of the ball. Okay, let's say for example, if you do not want to actually obtain the speed of the ball, velocity of the ball using using displacement time graph, you can do that. Okay, you can actually directly obtain from the velocity time graph. Okay, again, you see there's a mass of data. Okay, just remove the data that you don't want. Okay, and you see that this is the velocity time graph. Okay, of the ball. As you can see, again, it fits the pattern. It actually travel pretty fast. Okay, there's some fluctuations, and then after it bounces off the floor, it travels slower. So how are we going to say find out the velocity? Okay, there are so many velocities that's over here is fluctuating between 3.4 and 2.6. So what you can do is actually you can analyze, instead of doing curve fits, you do statistics. Okay, and the statistics is maybe the statistics of this bunch of data, and you can actually have a look, okay, on this, and you check on the mean. Okay, as you can see, the mean of these sets of data is actually roughly about 3.02. Okay, recall that when we use the gradient method, it is roughly about 3.04. So it's actually pretty close. Okay, same thing. If you want to find out what is the velocity after it bounces, okay, you can click on it. Okay, and then check on the mean. And you can see it's roughly about 0.82. Again, it's pretty close to the 0.7 plus, okay, that we obtained earlier. Okay, notice that actually there are two data that's actually missing over here. So it's because due to the clicking is very quite okay. So you can actually incorporate that. So you see again it's 0.80. So this is another way of using statistics, the mean, okay, the mean average, okay, meaning average of the speed to find out what is the what's the average speed that's actually, what's the average velocity that's actually the ball is traveling, okay, directly from a velocity time graph.